Hello dear children, we are going to discuss the numericals in current electricity, that is from NCERT in text sample questions. Okay, so here the first question is regarding drift speed. So the question goes like this: estimate the average drift speed of conduction electrons in a copper wire of cross-sectional area 1.0 into 10 raised to meter square, carrying a current of 15 ampere. Assume that each copper atom contributes roughly one conduction electron. The density of copper is 9.0 into 10 raised to 3 kg per meter cube, and its atomic mass is 63.5 U. Compare the drift speed obtained above with the thermal speeds of copper atoms at ordinary temperatures. Second one, speed of propagation of electric field along the conductor which causes the drift motion. So the question is about calculation of drift speed. Okay, as we know that what is drift speed. So the average speed with which the electrons are drifted. Okay, so we can calculate the drift speed. So when an external electric field is applied in a direction, we are applying an external electric field in this direction. So as we know, the electrons will be drifted in a direction just opposite to the direction of external electric field. So if external electric field is in this direction, that is towards right, the electrons will be drifting from left to right, that is in the opposite direction, in a direction just opposite to the direction of external electric field. So we can say that the electrons will be drifted from right to left once you are establishing an external electric field in a direction that is from left to right. So the electrons will be drifted in just opposite direction. So the electrons, as we know, it will not be moving with a constant speed, but it will be moving with an average speed called drift speed, and we are indicating this drift speed as BD. So the electrons will be moving in a direction just opposite to the direction of electric field, and as we know, electric field is in a direction of decreasing potential. As we know, electric field is in a direction in which the electric potential decreases. Okay, so if electric field is in the direction of decreasing of potential, then what can you say about the direction of this electrons? Electrons are in just opposite direction, moving in just opposite direction, so we can say that electrons will be drifted in a direction in which the electric potential increases. Okay, so leave it just for information. So electric field is established in this direction, electrons will be moving drifted in this direction, and as we know, the drift velocity has got an expression Vd is equal to I by NEA. So what is I? Drift current of electrons contributed by the electrons. Then Ne is the number density. What do you mean by number density? It is the number of charge areas per unit volume. So here the charge areas are electrons, so we can write it as N equals N by V. Okay, so that is number density. Okay, then what is E? E is actually the electric charge, that is for electron it is minus 1.6 into 10 raised to minus 19 coulomb. So leave that sign, you can write it as 1.6 into 10 raised to minus 19 itself. Then A, what is A? A is the area of cross section. Okay, area cross section. So in this question it is given as 1.0 into 10 raised to minus 7 meter square. So it is also given. Then I, the electric current, which is given as 1.5 amperes. So all these values are given. Okay, so now we need to find this N. Okay, n is not given. So how can we find n? As we know, n is number of charge areas per unit volume, and here the charge areas are electrons, so you can write it as n by v. So n by v, as we know, this v is volume. Okay, and how can we find volume if it is not given? So as we know, density is given by mass by volume. So from this, what is volume? It is mass upon density, and here the density is given. Okay, here the density is given. So when you substitute this expression in this equation, let us call this equation number as 1, then you will get n equals n divided by what is v? It is m by rho. So you'll get n by small letter m into rho. Okay, this rho will come as numerator. Then so all these values are given. Density is also given. You can see the density value in this question. So density is also given. What is the value of density here? It is 9.0 into 10 raised to 3 kilogram per meter cube. So now there is another problem. So what is that problem? We don't know what is m. Okay, we don't know what is m. So actually m is given in atomic mass unit as 63.5 U. So if it is given in atomic mass unit, then you can take it in gram atomic mass unit also. So the gram atomic mass equivalent of this is m equals 63.5 gram. So gram atomic mass unit. Now this is gram atomic mass unit. So here you can see density is expressed in kilogram per meter cube. Okay, kilogram per meter cube. So this is SI unit. Now what we got in place of mass, which is in gram, so we need to convert it into kilogram. So how can we convert it? 63.5 into 10 to the power minus 3 kilogram. So once you substitute these values in this equation, you will get the number density as n divided by 63.5 into 10 raised to minus 3 kilogram. Okay, into 9.0 into 10 raised to 3 kilogram per meter cube. Okay, now what happened is, now we need to know the value of n. So what is n? Actually it is the number of charge areas. Okay, total number of charge areas, and here it is said that each of this copper atom contributes 1 electron. So if there are 10 copper atoms, then how many electrons will be there? How many charge areas will be there? 10. But we know that if 63.5 gram is the gram atomic mass unit, so it can be taken as 1 mole also. Okay, corresponding unit is mole. So when you take this in moles, as we know, 1 mole of a substance contains number of particles as how much? 6.023 into you can take it as 6.0 itself. Okay, for simplicity. So 6.0 into 10 raised to 23 atoms will be there. So when you take 1 mole of copper, then it will contain 6.0 into 10 raised to 23 atoms. So if there are 1 moles of, when you take 1 mole of a substance of copper, it will contribute 6.0 into 10 raised to 23 atoms, and each of these atoms will contribute 1 electron. Okay, so this 1 electron, which is the charge area here, so 1 atom will contribute 1 electron. So how many electrons, how many charge areas? N will be there, since each of these will contribute 1 electron. So what is the total number of charge areas contained in this 1 mole of copper? it will be 6.0 into 10 raised to 23. You know how? Because one atom contributes. It is in the question that one atom gives one charge carriers, okay, one electron. So if there are 6.023 into 10 raised to 23 atoms, then each of the atom will contribute one electron. So how many charge carriers, one electrons will be there? Equal to 6.023 into 10 raised to 23 atoms, or you can say it as 6.0 into 23 10 raised to 23 charge carriers will be there. Okay, so charge carriers, here the charge carriers are electrons, so this much electrons will be there. So now we can calculate the small letter n. So how can we calculate the small letter n? N equals, you can write it as 6.0 into 10 raised to 23 divided by 63.5 into 9.0 into 10 raised to 6 kilogram. So how you got this? When this 10 raised to minus 3 goes as numerator, this will become positive. Then along with this 10 raised to 3, it will become 10 raised to 6. It will be 10 raised to 6. Now when you calculate this n, it will be 8.5 into 10 raised to 28 meter raised to minus 3. Okay, so we got the value of n. So once you got the value of n, you can substitute these values in the expression for drift velocity, so that you will get the answer as 1.5 ampere upon 8.5 into 10 raised to 28 into 1.6 into 10 raised to minus 19 into 1.0 into 10 raised to minus 7 meter square. So when you calculate this, you will get 1.1 into 10 raised to minus 3 meter per second, which will be approximately, you can write it in millimeter, you can write it in millimeter also. So it will be, since this 10 raised to minus 3 can be meter, can be called as 1 millimeter, so you can write it as 1.1 millimeter per second. So this drift velocity now it is expressed in millimeter per second. Okay, so you got this. So what are the steps we followed? I will explain to you once more. So as we know, the electrons are drifted in a direction just opposite to the direction of external electric field you apply, and we have the expression for drift velocity, which is Vd equals I divided by NEA. And what is this n? It is the number density of charge carriers, which is given by the total number of charges divided by volume. Okay, and we don't know how much is the volume, so we will express this volume in terms of density, which is V equals m upon rho. So this rho is given as 9 into 10 raised to 3 kilogram per meter cube. It is given in the question. So you can substitute for rho. Then we don't know the mass in SI unit. So as we know, the mass of copper is 63.5 U. So you can express this in gram atomic mass as m equals 63.5 gram. So it is 63.5 into, instead of this gram, we can convert it into kilogram, which is 10 raised to minus 3 kilogram. Okay, so now we can find the value of n. All these values are given except the value of capital N. So what is capital N? It is the number of charge areas contained. So how can we calculate the number of charge areas? As we know, in the question it is said that each of the copper atom contributes one electron. Each of the copper atom contributes roughly one electron, one conduction electron. Okay, so there is only one valence electron, as you can conduction electron. Okay, that can be utilized for conduction purpose. So as we know, 63.5 gram of copper contains how many atoms? So if this is expressed in atomic mass unit, which is in this case it is gram atomic mass. As we know, 1 gram atomic mass contains equivalent to 1 mole of substance. When you are taking 1 mole of a substance, as we know, this 1 mole of a substance contains 6.023. You can approximate it as 6.0 into 10 to the power 23 atoms. So if one atom contributes 1 electron, so how many electrons will be there if there are 6.0 into 10 raised to 23 atoms? It will be 6.0 into 23 electrons. So when you substitute these values in this equation, in the expression for Vd, so you can calculate the number density, that is number of charges per unit volume. So all these values are given. This 10 raised to minus 3 appears as denominator, it will go up and as numerator, and along with this 10 raised to 3 it will become 10 raised to 6 kilogram. So the number density will be 8.5 into 10 raised to 28 per meter cube. So when you substitute all these values in the expression for drift velocity, you will get the value of drift velocity as 1.1 into 10 raised to minus 3 meter per second, which is 1.1 millimeter per second. Okay, now the second part of the question. What is the second part of the question? We will discuss the second part. Compare the drift speed obtained above with thermal speeds of copper atoms at ordinary temperatures. Increase the speed or energy of the electron. So energy of electrons moving is given by the expression, as we know, when the electrons are moving it will get kinetic energy, and the average value of kinetic energy when you are calculating it is equal to half mv square, and this value will be equal to 3 by 2 kbt. 3 by 2 kbt. In this equation you have learned in your 11th grade. So when you take the value of v square from this, it will be half get cancelled, so you will be getting 3 kbt upon m. Okay, now when you calculate this v, you will get root of 3 kbt divided by m. So it is approximately order only, it will be of the order of kbt divided by m. Okay, so it is of the order of kbt divided by m. So where kb is Boltzmann constant, as we know kb value is how much? 1.38 into 10 raised to minus 23 meter square kilogram per second square per Kelvin. So this is the unit of Boltzmann constant, and this is the value. Now what is the value of m, that is mass of copper? So when you are considering the mass, you can calculate mass of one atom of copper, that is 1 mole of copper divided by 6.02 into 10 raised to 23. So when you calculate this value, it will be you just remember the value only, no need to remember the steps. If you know how to, then you can remember. Okay, so it will be approximately 1.055 into 10 raised to 25 kilogram for one atom of copper. So as we know, how many atoms are there? Yes, it is 6.023 into 10 raised to 23 in 1 mole. So you can calculate the mass also. So when you substitute these values in this equation, the value of v, that is the thermal speed of these electrons, will be of the order of is approximately about 2 into 10 raised to 2 meter per second, and this speed is at normal temperature. When you substitute this T as ordinary temperature, as we know it is 27 degrees Celsius. Suppose you are taking it as 27 degrees Celsius, and equivalent to this 27 degrees Celsius, the value of temperature in Kelvin is 300 Kelvin. Is it so? 273 plus 27 will give you 300 Kelvin. So when you substitute this T as 300, m the mass of copper, then kb, as we know the value of kb. All these values, when you substitute in this equation, you will get the value of v, that is thermal speed of electrons, as 2 into 10 raised to 2 meter per second. So now you can compare the speeds, thermal speeds as well as drift speed. So when you compare these two, you can see that this order is 10 raised to minus 3, and this order, what is the value? 10 raised to 2. So how can you compare it? So which one is lesser? Definitely the drift speed is lesser. So drift speed of electrons is lesser, and it is lesser about 10 raised to minus 5. Okay, so when you multiply this with 10 raised to minus plus 5, you will get it as 2 into 10 raised to 2. So this much is smaller. 10 raised to 5 times the drift speed is lesser, or you can say 10 raised to 5 times larger the thermal speed when you compare it with drift speed. Okay, so drift speed is 10 raised to minus 5 lesser compared to thermal speed. Otherwise, thermal speed is 10 raised to 5 times greater than this drift speed. Okay, so drift speed is lesser. That is the answer to second question, second part of the question. Then the in second part you can find two questions. First question we have already answered, that is the thermal speeds are high compared to the drift speed at ordinary temperatures. Then speed of propagation of electric field along the conductor which causes drift motion. As we know, when you switch on a bulb, you can see the light instantaneously, right? Okay, we cannot feel any time lag between switching and getting this light from the bulb. Okay, so you can imagine how much faster will be the energy transmission from the switch to the bulb. Okay, so electric field, as you know, when you switch on a bulb, the electric field will be transmitting with a speed of electromagnetic radiation, which is speed will be 3 into 10 raised to 8 meter per second. As we know, all electromagnetic radiation in free space will be transmitted with a speed of 3 into 10 raised to 8 meter per second. So electric field is also transmitted or established in this speed, with this speed. So when you compare the drift speed, it was 1.1 into 10 raised to minus 3 meter per second at ordinary temperatures. So when you compare these two, we can see that the speed of electric field is when you multiply this with 10 raised to 11, you will get the value. Okay, so in order to get the speed of electromagnetic radiation, or the speed with which the electric field is established, you have to multiply it by 10 raised to 11. So the speed with which the electric field is established, or electric field is traveling along the conductor, has got a speed of electromagnetic radiations which is 3 into 10 raised to 8 meter per second, and which is 10 raised to 11 times greater than the drift speed. Or you can say the drift speed is 10 raised to minus 11 times lesser compared to the speed with which the electric field is traveling along the conductor. Okay, so which one is larger? This one, that is the speed with which the electric field is traveling along the conductor will be larger. Okay, so these were the three questions. So I think this is clear to you. If you have any doubts, you can comment it. Okay, thank you.